this is where we ended yesterday. What's the difference between chemical and physical properties? One word starts with I. Interaction. Super. Okay, we did properties, now we're doing changes. Our first type of change is a physical change. Here's the key word if you're a highlighting person. Bonds and not. We're not doing anything with the bonds here. We're not forming them. We are not breaking them. But we are doing some sort of quote-unquote change. And over here, I have a nice little piece of paper in a fun way to show the way the paper can be changed without doing anything to its bonds. So I can make a paper airplane. I can rip a piece of the paper. I can crumple the paper up in a ball. The paper is still the paper. In chemistry, the biggest type of physical change is when you change from state of matter. And we reviewed that yesterday. Let me just pick one change of state. And you tell me what it's called, what the temperature is called. What is the temperature called when a gas changes to a liquid? Kenny, your hand is up.
Condensation.
Woohoo! What's the opposite of condensation? If you go from a liquid to a gas?
Evaporation.
Evaporation, okay. Anytime you're doing anything like that, you are not physically changing the matter, you're changing its state. So this involves a kinetic energy change, molecular movement, and distance. Let me just quickly show you what I'm talking about. And if you want, you might want to look at your definitions of solid, liquid, gas. Does anybody see my molecular models of water? Here they are. That was easy. What does a solid look like in terms of particles? Molecular distance, what's it look like?
I think they're very close up.
They are.
Packed together.
Right, and then we had talked about, is the arrangement random? That would be amorphous. Or do we form some nice patterns, which water actually does form patterns. Water forms ice crystals, and that's a pattern. So your solid generally is close together. What about the energy in this solid? Are the molecules moving? They are moving, you can't see them, and they are moving very, very weakly. But they're kind of just, you know, always little vibrations, right? So what happens is they start to change state. I'm not going to touch the bonds in the water, so what will happen?
I think they speed up.
Yeah, they're going to start speeding up, and when they start speeding up, the distance actually increases. So in the liquid state, they're moving around a lot more. And then what happens with the gas? Well, then they get sped up so fast that they, they actually just start flying out. And then that's why you see boiling and bubbling and all this, because now the thing is going all over the place. So that's what you're doing, but you're not touching the water molecule itself. It's staying completely intact. Mixtures. Anytime you form a mixture, you are simply physically changing. Why? What am I not touching when I add something and I create a mixture? What does not happen to the substances being mixed together? Bonds are not formed or broken. So when I add salt here, I'm not touching the bonds, I'm just creating a mixture. Is that clear? All right. You have 10 techniques of physical separation. They're in your vocab sheet. This will get you ready for your next quiz. Page ready. You're back in unit 0, man. Let me see where we're at. 10 techniques of physical separation are on the bottom of page 4. As a little bit of a warm-up, you guys have them listed here and to help get you studying. And then you also have the definitions on the next slide, right? Why don't you just take 5-10 minutes and match some up to warm your brain up. We'll read through them and then I'll give you a quick demo on some of them, what they look like. I'm gonna pause this and we'll turn it back on, okay? Yep.